My Kioti tractor needed some attachments for the front. Since it has a removable bucket, I decided to DIY and make my own attachments. I wanted at least 3 things attached to it. So I wanted one universal attachment, which would allow different things to be attached to that. So it's sort of a quasi-quick release. This quick release device includes a 3-point hitch assembly. This way anything that can be put on the back of the tractor can be put on the front of the tractor, such as a rake, or a lot of times it's better to reach out with the front to do your raking than trying to back in with the rear wheels to do your raking. In any event, I combined these 2 features together, and this is a picture of the final product. We'll discuss how that was done in a few more minutes. I wanted a set of adjustable forks, but they were way too expensive. They were over $800 plus shipping. So I decided I'd just make my own. So this video will show you how I made my own forks. I also wanted a fork system to rake with, but it's too hard to twist your head around looking behind the tractor trying to rake things, and plus it limits your access. So I decided to build a DIY front-mounted fork system that I don't have to twist my neck. I can easily move the forks left or right as I move into an area. And last but not least, my pond has some issues. Notice the weeds growing up through the water while the pond is filled. So I have to fix that problem. Here it shows the dirt in the bottom of the pond when the pond is mostly empty. These dirt piles are a result of having to get the mini excavator out of the pond when it started raining heavily for 3 days in a row. So I had to get the excavator out. I didn't have time to fix these 2 dirt piles. These dirt piles had to be removed, so the only thing I could figure out was to build a contraption that looks like this. The walls of the pond are too steep to drive the tractor down in, so I had to do it remotely with this contraption. Okay, here you can see the tractor side of the quick disconnect mount. There's a pad on each side, and here's the actual do-it-yourself disconnect unit. Across the top there's a 1.5 inch by 3 inch channel iron, and vertically on each side there's a 1.5 by 3 inch channel iron, and they're butt welded right here. Across the bottom we have a 2 inch square tubing. It's 3/16 inch thickness, and that serves as the bottom plate. And mounted between these 2 we have this 3-point hitch assembly, which I purchased from Amazon for $69. This hitch assembly also has a receiver, a 2-inch receiver socket right there in the middle. So this allows 3-point connectivity to this do-it-yourself adapter. Here you can see an end view of the DIY adapter. And notice that the vertical channel irons, we have a 1/2 inch steel plate across the top of the channel irons. And this little guide here, that's just what allows it to center on the tractor when you're trying to hook it up using the tractor. Here's a picture of the unit lying face down. Notice we have the vertical channels right here. We have a horizontal top channel there and the square tubing at the bottom. And the 3-point hitch is welded to all these pieces. Here's a picture of the tractor side of the adapter. And here's a picture with the do-it-yourself adapter attached to the tractor. Notice how the 1/2 inch steel plate just has been formed to shape around the same curve the tractor has. So this concludes how the do-it-yourself adapter was manufactured. Now let's find some uses for it. Now we would describe how the forks are manufactured. The forks are 2 separate elements. They just hook onto the do-it-yourself adapter assembly, as shown in this picture here. I took 2-inch square tubing, 3/16. This just happens to be what I have in stock. And I took my plasma torch and use wheel adapter. And if you notice, it's slightly off center if you put a straight edge on the one side. So I cut the 42-inch length of square tubing, and then I went ahead and split it down on each side. If you notice in this picture here, the 2 sides are different lengths. This side is longer than this side. So by cutting it with the offset, then they overlap perfectly and I can weld them together. And it makes it very strong, twice as strong, basically. Here we have a picture of the entire fork, and you can see how the end of the fork is tapered, so we basically have like 1.25 inch fork thickness, which is more than adequate for most situations. Some of you may be wondering why the bottom piece isn't as long as the top piece. Well, I didn't have enough to do 4 43-inch pieces, so I had to do 2 36-inch pieces and 2 43-inch pieces. So that's why the bottom's shorter. I still have plenty of strength. The strength, is in the middle and the back part of the fork. As strength isn't nearly as important down at the end of the fork. Here's a side view of both forks installed. Notice that we have this vertical section of the same size tubing goes up, and then there's more of the same size tubing across the top. And then right here we have the same size tubing, which causes reinforcement at this 90-degree point. Here's the top end of the fork, and notice it just hooks over the edge of the top channel iron, which connects the fork to the DIC, do-it-yourself assembly. Here's another view of that connection. Right down here there's a hook that goes, that's only 1/4-inch steel, so I bent it down underneath, hooks onto the channel. And then I put a thicker piece of angle iron here to reinforce that piece, and then another reinforcement piece on top. So this is very strong, because that's where all the pressure is. So this concludes my fork manufacturing video section. I've lifted 500 pounds on the tips of the forks with no incidents, so I'm pretty sure they'll handle anything this loader is capable of lifting, which I think is like 1,200 pounds. Okay, next we'll address the rake construction. I wanted a rake that had tines closer together. The rakes you buy have fewer tines. These have 21 tines, and they're the width of the rear wheels so that you can't see my tire tracks. So this rake cost me $9 a tine times 21 is basically $189 plus tax. The rest is all scrap material. So let's discuss the details. The rake was near sand during a rainstorm, so this is sand splatter, this gray stuff on here. This is the top view of the rake showing how it's bolted to the subassembly. And here we have an end view of the rake. If you look closely, the rake only consists of basically 3 parts. We have angle iron here on the left, we have square tubing 3/16 in the center, we have angle iron on the right. And those 3 pieces form the backbone, along with these 3 pieces here on the bottom of the square tubing, which connects to the 3-point hitch assembly. So that's really the construction of this thing. Here's a picture of the frame mounted to the 3-point hitch assembly. I used, I think they're 1-inch bolts on the bottom to bolt instead of pins on the bottom of the hitch assembly, and a normal pin hitch on the top. So that's what fastens it to the quick disconnect assembly. Here you can see the holes in the rear angle iron assembly, which is welded to square tubing. And we notice there's some gussets right here to increase the strength, since the tines will be pulling on the top of this angle iron. Next you will see the spline allocation nuts. These are nuts I simply welded onto the top of the square tubing once I had the tines in position. This keeps the tines from twisting on the bolt and changing their spacing. And last but not least, here is a view of the forward angle iron welded to the square tubing. There's a 1/4-inch steel pin that runs up and is welded to connect the 2 together. This keeps the tines from twisting up as you use them. And that forward angle iron is shown here and holds the tines from kicking up. So this concludes the discussion of building my own rake. So now here we are left with building the pond scraper. I needed something very heavy, such as this cast iron table off this old table saw I got out of the dump. So this is heavy enough to do the job, and it's just about the right size. So I incorporated it here as shown. As shown here, I just chained this saw tabletop to these rakes, which were assembled onto the end of this boom, and that held it in place enough to use it. As can be seen in this picture, I simply took the rakes off the drag box at the back of the tractor and used a 1/2-inch bolt with spacers between the rakes and bolted them to the end of this 14-foot trailer square tubing, 2 by 3-inch trailer square tubing. This gave me a pivot point. Then I took the top of the hole on the rake bits, and I ran another 1/2-inch bolt through that and through another piece of 2 by 3 inch square tubing. And that allowed the rakes to dig into the dirt and tear up the dirt. And then later on I came back and added the scraper to it, and then the scraper allowed me to finish the job. This was very crude but very effective. It worked quite well. The scrapers definitely tore up those dirt piles in the bottom of the pond and allowed me to scrape them later using the scraper. So the scraper and the rakes together, the rakes support the scraper, and the rakes also loosen the dirt first before I put the scraper on. So this was a good combination. This 12-foot boom was attached to the tractor using this adapter through the receiver of the 3-point hitch assembly. Then I simply used a bunch of chains, 3/8-inch chains, to connect the boom so the boom would be lifted by the do-it-yourself adapter. And this combination worked quite well and it did the job. The pond got corrected the way it needed to be corrected. So this concludes this video. I hope you found it interesting, and hopefully you can find some benefit from my ideas in building your own.